Hey everyone, we're going to look at number 18 in section 4.5. We're going to evaluate this limit right here. The limit is x goes to infinity of x to the 11 divided by x power. Well, as x goes to infinity, clearly x, the base, is going to infinity, but 11 divided by x, right, that limit is clearly 0. This is an indeterminate form, right? The base is trying to make this expression go to infinity, right? Larger and larger base. The exponent, though, anything to the 0 power is approaching 1. And so since the exponent is getting closer and closer to 0, it's trying to get the limit to be 1. So is the limit 1? Is it infinity? Or sometimes it could be something in between. Well, the way to deal with these types of limits, this is not L'Hopital rule form, right? L'Hopital rule form is 0 over 0 or infinity over infinity. So to help us out, we use logarithms, and we're going to use the property of logarithms. We've used it many times. If I have the natural log of some expression raised to a power, this is the same thing as n times the natural log of a, right? That's an important property of logarithms, which comes from the property of exponents, that if you're raising an exponential expression to another power, you multiply the powers. And remember, the natural log of a is indeed the exponent on the base, in this case e, needed to get a, and so we're multiplying it by n. Okay, so I'm going to make use of that. I'm going to let y be the limit that we're trying to find and take the natural log of y. Well, if I take the natural log of this, I can bring the natural log inside this limit because the natural log is continuous on its domain, and we're fine because the domain is everything greater than 0, and we're going to infinity. So this is the limit as x goes to infinity, natural log of x to the 11 over x power. So I'm going to use this property, and this is like my n, my power. I'm going to bring it down in front, right, using this property here. Now, as x goes to infinity, 11 divided by x, we said, is going to 0, right? So this is 0. And natural log of x, that's going to infinity. Remember what the natural log of x function looks like, right? At 1, we're equal to 0. So if this is 1, we're equal to 0 there. Of course, if I'm approaching 0 from the positive side, I'm going to minus infinity. We have a vertical asymptote at x equals 0. But as x increases, we continue to increase gradually, but we do continue to go to infinity. So the natural log of x is going to infinity as x goes to infinity. This right here is, again, an indeterminate form. This function is trying to make the limit be 0. This function is trying to make the limit be infinity. It could be 0, it could be infinity, could be something in between. Well, this is not L'Hopital rule form again. So what do? Well, a simple rewriting of this expression, we'll put it in L'Hopital rule form, because 11 divided by x times the natural log of x is the same thing as 11 times the natural log of x over x. Just think of the natural log of x as being the natural log of x divided by 1, right? Just multiply the numerators, multiply the denominators, and this is what we get. Now, as x goes to infinity, 11 times the natural log of x, as we said, is going to infinity, and x is going to infinity. This is L'Hopital rule form. So you've got to get in that form to use L'Hopital's rule. Now, how's L'Hopital's rule work? We take the derivative of the numerator, right, which is 11 times what? The derivative of natural log of x is 1 over x. So 11 times 1 over x is 11 divided by x. Over the derivative of the denominator, derivative of x is just 1. So as x goes to infinity, this is going to go clearly to 0, right? 11 divided by something going to infinity is going to 0. Now, real important, that's not our limit. Remember, our limit was this. We called y, but we have the natural log of y. So the natural log of y is 0, which means y is what? E to the 0. Remember, the logarithm is the exponent on our base. In this case, natural log, the base is e. E to the 0 is, of course, 1. So that indeed is the value of the limit. Okay, so again, hope this is helpful in doing this one.